yeah, or blur your name if you appear there. So, well, yeah, let's begin. 406. Yes. Okay, I'll share my screen. Yes. Can you see my screen or no?
Yes, yes.
Yes, it's all good. Well, welcome everyone, and thank you for being present on our first webinar of the French IWA-Astee chapter. So today we'll be having a nice webinar, but let's first present ourselves. We're part of the International Water Association Young Water Professionals. We're on part from a global network related to the water sector, with all this implies. The idea of this network is to provide opportunities for professional development, networking, and collaboration to improve water management and sustainability worldwide. So welcome here. We were founded in 2022 to support and engage young water professionals in the country in France, obviously. So we are currently developing networking events, technical workshops, and social activities to foster collaborations and opportunities between the members. We're organizing webinars and mentorship to enhance professional skills of young water professionals, and we're trying to be a representative voice of young water professionals in the sector in policy discussions and for promoting sustainability water and management practices. We're committed to empower and support the next generation of water professionals through driving innovation and sustainable solutions for the water sector in the country. Our very brief and short history. So in 2022, we initiated contacts and first meetings. In July 2023, we wrote the first document of the chapter. The first official document stating the current, not the current, but at the day the positions of each one member in the chapter. The first workshop was organized during the 103rd ASTee Congress in Quimper, France, which is roughly translated to promoting the international cooperation of young water professionals. And in September 2024, the chapter participated in professional career profiles with the Spanish, Nigerian, and Swedish chapters. And today, we're hosting our first webinars. So the key activities is cooperating with other young water professionals across the world and hosting workshops, as we've already mentioned. And we are currently 12 active members. And today, 2 of our members will be presenting you around the subject of water scarcity, Assia Mokssit and Chloe Meyer. So thank you, and you can find us, please, in LinkedIn, follow us, and to get any news and any opportunities around the water sector. So now let's go to the main event. I'll stop sharing now. So we'll begin with Assia Mokssit. So who is Assia? She has a comprehensive background in water and environmental engineering, supported by a PhD in hydraulic engineering from École Nationale des Ponts et Chaussées. She has a double master's degree and 9 years of professional experience. Currently, she serves as a research and water performance expert at SUEZ Technical Distribution Center, where she spearheads innovation projects aimed at optimizing water network performance and management. Assia has worked on various projects in countries such as India, Algeria, Senegal, Morocco, Mexico, and the USA, Italy, and France. She is also an active member of the management committees of 2 IWA specialist groups, namely water loss and intermittent water supply, where she collaborates closely with academics, operational experts, and regulatory representatives in the water sector to drive practical solutions and advancement. So, without further ado, I'll leave you with Assia.
Thank you, Pablo. So I'll try sharing my screen.
Oh, I forgot. Any questions you have, please write them on the chat, and I'll present the questions later for everyone. Okay.
Wait, I need to switch it here. Do you see my presentation in presentation mode?
All good.
Yes, great. So as I was saying, thank you, Pablo. Thank you all for coming to our very first webinar. And as Pablo was saying, I'll be presenting today, I'll be doing a presentation about water loss management with the idea of optimizing water network performance for a water-scarce future. So I'll start here with a very contextual slide. As you can see on the right, we have the Sustainable Development Goals that have been identified and have actually identified KPIs that are agreed upon between several countries. The sixth one focuses on water and sanitation for all, with its fourth point insisting on increasing water use efficiency for 2030, which is virtually in 5 years now. So keeping that goal in mind, utilities face constantly evolving challenges, such as the need to adapt to climate change and the water stress and extreme weather phenomena it entails. We also have challenges related to coping with the pace of population growth, including urban expansion and migration. We also have financial pressures induced by the global economy, and the user expectations are actually evolving in terms of service improvement, and there are also some political pressures related to more tariff reduction. All of this while water service has an aging infrastructure impacting the overall sustainability of the service. So this is why we're looking at water loss in order to be in harmony with the sixth SDG. So talking about water loss, it's a critical issue that can have significant impacts on water availability and financial sustainability. So here, excessive water loss, which is often due to aging infrastructure, leaks, and inefficient use, can lead to water scarcity, which impacts consumers. This, in turn, can result in higher water bills, increased operational costs for utilities, and potential water service disruptions. And even if we go even further, it can make a network switch to what we call intermittent water supply, which is very hard to come back from once it's established. So here is a very short animation to illustrate what we talk about when we talk about non-revenue water. So if we equate the drinking water available on Earth to the content of this glass, a figure that comes often is that we are, quote unquote, losing more than its third in the networks, which is equivalent to $14 billion per year. Actually, I saw lately an even greater figure, which was $39 billion per year. So in a paper published in 2019. So this is just a minimum consideration. And saving only half of this minimal consideration would actually amount to to 200 million more people that could be supplied without draining resources, and this is equivalent to basically 25 times the population of New York. So this is the global idea, but the truth is, when we talk about non-revenue water, this figure entails real physical losses, so real amounts of water that are lost, but also what we call apparent or commercial losses, which are more related to losses in income. But something which needs to be taken into account is that even though apparent and commercial losses are not directly related to amounts of water, they are crucial. I mean, reducing them is crucial to allow the utility to keep its sustainable financial capacities. And this means that they would be able to invest in all the actions that are needed to reduce the physical water losses. So here, just to say that when we talk about non-revenue water, we must take into account physical losses as well as apparent losses. So keeping that in mind, there are a lot of benchmarking tentatives, but NRW benchmarking has strong limitations. So this graph here shows figures of NRW percentage per world region. However, benchmarking countries, and here even in some cases we have continents as well. So benchmarking those continents to compare their NRW level can be tricky due to data availability, different methodologies that are implemented, and some contextual factors. And an accurate and meaningful comparison requires a common methodology and data quality standards. So these figures need to be taken with a grain of salt. Now, when we talk about standardization, this is where the IWA, which we are part from, so the International Water Association, comes into place, defining standards for the management of NRW. Here in this slide, we showcase the basic actions for water loss control that were defined by the IWA. So there are 4 actions per water loss category, 4 for physical losses and 4 for commercial or apparent losses. When it comes to physical losses, the first action is the speed and quality of repair. There is also active leakage control, pressure management, and asset management. And when we talk about apparent losses, there are errors in data acquisition that need to be taken care of, unauthorized consumptions and frauds, customer metering errors, and also poor estimates of unmetered consumption. So here in our presentation, we will be really focusing on the physical losses part of the NRW issue. And here this slide shows the global approach that we use in SUEZ, but it's basically the traditional one that everyone uses. So the global approach implemented here is described in this figure. There is first an assessment step, allowing for the definition of the optimal combination of actions according to the existing level of efficiency in the system. And then we have below, at the bottom half of the slide, the actions that are carried out as we saw them in the previous slide. So these actions cover first leakage management, which entails leakage mapping, detection, and reparation to enable a quick response and reduce leakage runtime. We also have pressure solutions, which include advanced pressure control to minimize stress, leak frequency, and leak flow. Then we have asset solutions, allowing to identify weak assets to reduce break or burst frequency and maximize capital expenditures or investments. And finally, and we regroup them in one case, there are revenue solutions, which consist in identifying, detecting, and reducing uncontrolled and non-revenue volumes to increase revenue and allow the utility, as we said earlier, to maintain financial stability. So what we will see in the next slides are the details of each of the steps that are related to reducing physical losses. So here, the first thing is the assessment part. And in order to do that, we review this figure, which represents the common elements in a water system to identify the different sources of NRW. So as you can see, at the production or transport network, we can have metering inaccuracies at the source, leaks or overflows at the reservoir level, or losses on the mains. Then when it comes to the distribution network, we can have overflows or leaks at the tank level, but also leaks on the pipes, the service connections, and the accessories. And finally, at the customer level, we find the main constituents of apparent losses. So the assessment step here needs to explore each of these potential sources and evaluate the losses related to them, which actually allow us to draw a water bath schematics. So this is what you see here on the slide. Here you can see that the system input volume, so basically what we put in our system in terms of amounts of water, is divided into authorized consumption and water losses. And the NRW encompasses the unbuilt authorized part of the authorized consumption as well. So when acting upon reducing NRW, it's the dark blue part, basically, of the figure that we're trying to reduce. And this figure comes actually from the IWA's water balance, which allows us to detail the components of our system input volume. And this operation is crucial to conduct an assessment and have an idea of the system's current efficiency. And in order to do that, we have three main methodologies. So we can carry out either a top-down analysis, which is an analysis of real and apparent losses based on volumes from production data and consumption. Then the second one is the bottom-up analysis, which goes from the estimation of physical losses from parameters like the minimum night flow or pressures. And then the third one is called component analysis, and it is based on the estimation of each component, like leaks, pressure data, and meter errors, and it's developed using operational data. And ideally, an assessment would entail using at least two of these methods to complement the data and evaluate the NRW level of the system. So the assessment actually needs to gather operational, structural, hydraulic, and customer management data to come up with an evaluation of the current NRW level. This can be done using different tools. So the IWA Water Loss Specialist Group has a free tool called EasyCalc. At SUEZ, we use a tool called AquaCircle. But an important thing to keep in mind is the fact that it's not just gathering figures and filling out basically boxes in the tools that needs to be done. This assessment step needs experts going on the field to gather this data firsthand and assess the situation. So once this is done, the following step is to establish an action plan to improve the situation. And in order to do that, we will carry out also a forecast of the impact of these actions that were devised in order to devise basically the best course of action according to the targeted objectives. So this was it for the assessment. Now we will go through the different actions that can be implemented. And an easy way to look at it, if you look at the top of the slide, it's by dividing the losses volume or quantity into its components. So if you look at the equation, to reduce the volume of losses, we can either reduce the number of leaks, we can reduce the flow of the leakage, or the leakage runtime. And when it comes to leakage management, what we try to do is to reduce the leakage runtime. And this leakage runtime can be divided into an awareness time, a detection time, and a reparation time. And the idea in this step is to try and reduce the three of them. So the approach here is to carry out an analysis at the network level based on risk assessments for leakage mapping. And from there, the principle is basically to divide and conquer. So we carry what we call a sectorization process, or if you are more in an English-speaking country, this is where DMAs or district measured areas come into place. So we have leak pre-location, then a more accurate pinpointing when we go down in scale. And each step has adapted techniques and technologies going from, for example, satellite image analysis for leak pre-location at the zone mapping level to digital twins for the pre-location and acoustic field techniques or tracer gas for the pinpointing, or even sniffer dogs, if you heard of this. Once the leak has been found, all is left is to repair it. And the repairs should be completed as soon as possible after a leak is detected, as leak runtime, as we saw, affects the volume of physical losses. Another thing to keep in mind is that repair quality also influences whether the repair is sustained or not. So it is essential to consider several key factors to ensure the efficiency of the repairs. This includes the efficient organization of repair procedures, along with the availability of appropriate equipment and materials. So ensuring adequate funding is also critical to maintaining operations, and an adherence to standards for materials and workforce guarantees quality and durability of repairs. So the implemented strategy of policy should also emphasize having well-trained staff and committed management teams. And finally, maintaining a high quality of service connections ensures reliable and consistent water distribution. So this is basically it for leakage management. Now we'll go to the second action, which is pressure management. When it comes to pressure management, we have two things. So there is traditional pressure reduction or advanced pressure modulation, where the principle is very simple. It's actually the fact that by controlling the pressure of the water, we will be reducing the volume of water which is being forced out of the pipes through the leaks. So here we reduce the leak flow, And the correlation is rather straightforward. It's a square root relationship between velocity of the water coming out of the leaks and pressure. So this is for the reduction or modulation techniques. The second action is related to pressure transient management. And here, actually, it's more of something which is related to asset management, because transients or high pressure fluctuations are a stress element for the network. So by controlling them, we reduce the number of leaks. And this is what's so this is what we are displaying in this slide. So this requires going through three main steps that you see here. The first one being gathering the transient data using high-frequency pressure loggers in order to detect the transient events. Once these events, so this is the second step, once these events are detected, the following step is to identify the sources of the transients and devise mitigation solutions. And finally, a third step is sustaining the quote-unquote calmness of the network that was achieved. And here we go to asset management. So this is an action which allows us to reduce the number of leaks on the network. And it basically consists in devising an efficient network renewal strategy. So the idea here is to detect the pipes or network components that are the most degraded to replace them. In order to identify these pipes, inspection plans can be carried out. And here you will have a lot of technological possibilities that exist in the market. We can go from acoustic, electromagnetic, ultrasonic, or even transient techniques. And more lately, inspections even by drone or using fiber optics. But the difficult part here is choosing which pipes to inspect, because it's normally a costly endeavor. So we need to pick the right pipes to inspect. And after that, how to extrapolate the information from what was inspected to the entirety of the network. At this stage, we can use clustering and extrapolation algorithms. Once this is done, here comes the asset degradation model. So we will need a degradation model to be built to establish aging scenarios and forecasts. So try to forecast the risk evolution upon which the renewal plan will be established. Here as well, different models can be used, going from the simple multi-criteria analysis to statistical or AI-based models. And finally, because the renewal is an important investment line, optimizing this investment plan is the last step for an effective asset management strategy. So here we basically went over the main actions for physical water loss reduction. In the following slides, we will see some use cases where they were implemented and the obtained results. The first use case was in Bordeaux, here in France, where the 3,000-kilometer network was taken over by SUEZ in 2006, with an initial NRW level of 20% and an objective of reducing this NRW level. So an initial, of course, water loss assessment was carried out, and then the actions that were devised were deployed. So these actions consisted in implementing advanced leak detection activities and network sectorization, as well as implementing pressure modulation over 2 zones, covering 30% of the network, which gave actually impressive results. The third action was advising an optimized pipe and targeted surf connection renewal plan. And finally, implementing a meter renewal plan. It's also worth mentioning that these actions were all accompanied by real-time monitoring throughout the whole process. So here we go. This is a slide of the outcomes. So the NRW levels were reduced by 4.2% over the period. But the interesting thing is that the results obtained from each of the implemented actions at the NRW level were quantified. And as you can see here, we have pressure modulation, which is a pretty efficient action that was implemented. The second case study or use case is that of Arezzo in Italy, which is a semi-rural network with very low capex. The focus here was on new installations in order to expand the network and create new production plans. So there was nothing or barely nothing left for the network renewal. And also another thing which is important is that the NRW initial level was of more than 40%. to which we will add the fact that this was a region with very high water stress. So here, because as I was saying, the investment, we had an investment constraint, the network renewal rate was very low. So the focus needed to be on the other actions. In terms of leakage management, what we had is a very fine-grained sectorization that was implemented, going from 5 DMAs basically at the beginning to more than 150 DMAs at the end. And a comprehensive pressure management strategy was carried out. And the same, similarly okay, so in this graph here, what we see is that by 2022, more than 90% of the network was under pressure control. And finally, so similarly to Bordeaux, the NRW management as a whole was digitized. The figure here on the left is not really an outcome, but I really like this figure because, and I didn't really have enough space on the previous slide to put it there. It's a nice figure because it showcases the progressive reduction of pressure with an increasingly sophisticated modulation and the outcomes from there. So in 10 years, the average pressure went from 42 to 23 meters, and the performance and indicators of our SUEZ network as a whole were improved, with basically an important reduction in the pipe burst rate over this period. So 70% fewer leaks in the network and more than 70% reduction in the volumes of leaks. The NRW, if you can see on the figure, was at 17% or 16.9% in 2022. And this is my conclusion. So if I had to say something, is that with aging infrastructure, urgent investment in water networks is essential, even if it's not always a political priority. So reducing NRW requires a collective commitment, culture change, and strategic investments. This is to say that addressing NRW isn't just about fixing leaks. It demands a holistic approach that involves collaboration across all departments, from management and finance to operations and customer service. So within these departments, we also have HR, and actually empowering human resources to provide the necessary training and skills development ensures teams are equipped to implement effective NRW strategies. So if I had to sum up, I'd say that only through cohesive action and strong commitment can we make meaningful progress in preserving our water resources. Thank you.
Oh, thank you, Assia, for that lovely presentation. So we already have a question from Anjishnu. Hopefully I'm pronouncing it correct. I'll read it aloud for everyone. In general, NRW is directly linked with the water stress. Can it be related also with the demand of population? For example, water demand of urban population might be less as compared to the rural population?
Yes, NRW, there is a component which is related to water demand. So the very short and straightforward answer would be yes, there is a correlation with water demand and with the stress that is induced on the pipes.
Okay. Do we have any other questions? No, I have a question for you, Assia. So, so from all the different technologies that you presented, which is the best one? Like, how do we get to decide?
Okay, so I cannot give as a straight answer for this one, because actually technologies depend on the condition in which they will be implemented. So if I just give an example, in acoustic leak detection is very good with metallic pipes, but when we have an intermittent water supply, we actually need the pipe to be completely filled for acoustic leak detection to work. So in this case, other techniques like tracer gas could be implemented. But it's always, there are also very, in the market, there are new technologies that appear every year. And what we do at SUEZ is that we have a technology watch process where we follow the new technologies, and from there we try to detect the ones that are that could be interesting, and we carry out tests or field tests, so technological tests within our business units, so within the field, in order to gather the feedback from the operators as well. So I don't know if that answers the question.
Well, I thought that there was not the best, one of the best, but
No,
I think that
there
answers.
isn't.
Yeah, obviously, I thought of that, but yeah. Well, just to wrap it up, what is, in your view, the main obstacle for water loss reduction?
Okay, so this can be answered in two ways. There is okay, so the first thing is related to the fact that sometimes just doing the standards that were established from a long time, so a good pressure management, a good sectorization can actually, when it's done very well, can give us very good results. So we shouldn't be looking for technologies if those basic things are not carried out in the right way. And the second way to answer it is what I said in my conclusion slide. So it's related to the culture change and the fact that everything related with water loss reduction or NRW management in general requires different departments within the water utility and different stakeholders to have the same goal and to work towards this objective. So this can be a bit tricky to achieve.
Well, thank you again for presenting us today. Now I'll introduce Chloe. So Chloe is a senior researcher director at Bluefield Research. Her work focuses on supporting company strategies through water market intelligence, particularly in the municipal sector. Previously, she was a project officer in the UNESCO division of water sciences and worked on water resources governance and transboundary cooperation in the Mediterranean region. Chloe holds a Bachelor of Arts in History and a Master in Geography and Water Management from Paris Nanterre University. So, without further ado, Chloe, please.
Great. Can you see my screen?
I see it, yes.
Awesome.
Good. Remember to ask your questions during the presentation. Sorry, Chloe. I'll let you know.
Sure. Thanks, Pablo. So building on Assia's presentation on water loss management as a solution to water scarcity, I'm going to present another solution to this challenge, which is wastewater reuse at the municipal level. So a few months ago at Bluefield Research, we did a deep dive on the municipal reuse market with two of my colleagues. And we looked at the different trends that are shaping the market, we sized the opportunity, and we identified different business models that municipalities could leverage. And this is what I'm going to present to you today. So if we look at the different dynamics characterizing the market first, we see without much surprise that water scarcity plays a big role in pushing the market forward. The lack of water, whether it's seasonal or structural, increases the urgency around the implementation of non-conventional water solutions, like reuse practices, for instance. And this is particularly true in the Mediterranean region, but it also affects countries more up north, like the UK or Belgium, for instance, which is actually one of the most water-stressed countries in Europe. On one hand, so we have resources becoming more scarce from climate change, but on the other hand, also we have increased pressure on those as a consequence of demographic growth. The pressure on water also stems from economic needs for the agricultural sector and industries, particularly as countries explore high margin but water intensive development opportunities like mining or data centers. Despite those incentives to develop reuse, it's only recently that Europe introduced a regulatory framework with the regulation on minimum requirements for water reuse, which entered into force just over a year ago now, targeting primarily agricultural irrigation. There is still a number of applications that lack clear regulations right now in Europe, whether at the national level or at the regional level. And on top of this, we also see a lack of clear financing mechanisms. On average, most countries in Europe do not achieve full cost recovery for water and wastewater services. This can further hamper the development of reuse at the municipal level, as finding a viable business model is a challenge for utilities. Despite those hurdles, I think the opportunity, and more than this, really the need for reuse is bound to continue to develop backed by a large pool of wastewater infrastructure in the region. So taking those drivers and inhibitors into account, we forecasted the municipal reuse market opportunity, understood here as the capital investment into filtration and disinfection technologies, as well as pipes and tanks to reclaim municipal wastewater. Overall, we see a 1 to 2 billion market cumulatively through to 2030. Spain, France, and to a lesser extent, Italy offer the largest market opportunities in relation to the size of their asset base, exposure to water scarcity, as well as ongoing project development and investment trends. Portugal, Greece, some Mediterranean islands consist of smaller markets due to lower investment capacity and for some of those, a smaller asset base as well. Some countries already practice reuse at high levels, like Cyprus and Malta, leaving also fewer new development opportunities. If we look now at the forecast broken down by application, we see that agricultural irrigation is anticipated to remain the dominant reuse application, with just over half of reclaimed water volumes. Agricultural activities are uniquely positioned in that they are dependent on external sources of effluent for reuse, which is not the case for industries, for instance, which produce their own effluent that they can recover and reuse. In drought conditions, supporting agriculture with reclaimed water is also sometimes the only way to maintain local and regional economic activities, which underpins its support from the municipalities. That being said, a change in reuse approach is observed. There's an increasing share of projects shifting from being reactive to drought to being more forward-thinking, with cities in particular targeting sustainable development. And this has fueled interest in urban applications for reuse and circular economy. Urban applications are dominated by irrigation again, but this time for commercial activities like golf courses, stadiums, as well as landscape purposes. Those activities are often associated with a strong leisure or tourism economy, and street washing is also an application taken into account here, but it represents more limited volumes. The supply of municipal reclaimed water to industrial activities tend to be stronger in northern countries like Belgium and the Netherlands, although it also exists elsewhere in Europe. So to sort of conclude on this forecast, I think Europe is a maturing market with a mix of reuse utilizations country to country. The market here is generally growing at a rate that is indicative of opportunity. It's definitely several years behind the US, still delayed by slower advances in regulations and longer piloting stages as well. And the priority is and will continue to be in the near future agricultural support. Now, if we look at the business models for municipal reuse projects and the different opportunities they offer, we see that we've identified 5 end-use applications. So we have industrial applications, agricultural ones, urban, potable, and environmental applications as well. Essentially, what we did here is that we looked at the demand profile of each offtake type and how it impacts the overall business case or opportunity, because each type varies pretty significantly in their needs, from water quality, volume, seasonal demand, all the way down to the overall willingness of the end users to pay for reclaimed water. And our conclusion here, or the big takeaway, if I can say, is that there is off-takers that are using reclaimed water for industrial or recreational activities are the one that can generate the highest commercialization opportunity based on an optimum combination of characteristics. But at the same time, a low commercialization opportunity can still lead to a very strong regional value proposition and creation. Another elemental consideration of reuse projects is trying to find the balance between inherently competing objectives. By this, I mean that a sustainable rate to encourage the use of reclaimed water often conflicts with the ideal rate to manage water demand, as well as with the required rate to ensure cost recovery or even generate profits. This is where non-economic value creation really comes into play. Non-economic value creation encourages taking a system-wide approach or system-wide perspective at reuse and looking at the benefits that it brings to the local or regional area. It relies oftentimes on voluntarily setting a lower rate for reclaimed water and subsidizing it with revenue from domestic customers via taxes and fees, for instance. And this is exactly the approach that Singapore takes with its water conservation tax that applies to drinking water and wastewater customers. Another consideration is that of the portfolio balance. We saw earlier that different off-takers have different volumetric, quality, and seasonal demand requirements, and this can have implications on the overall risk balance portfolio of the scheme. As the share of reclaimed water supplied to a single off-taker increases, the commercial risk increases too, because revenue is then concentrated within a few off-takers, and there's less room to adapt in case of wastewater input shortage. However, if we think back to that earlier slide, a large off-taker such as an industrial hub, for instance, is a high-value customer from a business angle. So the benefit of taking on more risk in this case is also more financial reward. On the other end of the portfolio, where you have numerous small volume users, there's less commercial risk and more flexibility for water balancing. I think commercialization is optimum when there's a significant share of reclaimed water that is supplied to mid to high volume users with constant water needs and high value production output, leading to a certain willingness for the customers to pay for the reclaimed water. And now I have a few case studies to present to you to touch on the ways each utility considered these elements and how they are reflected into their business models and value proposition. So first, we are in Milan in Italy. So here at the beginning of the 21st century, so 25 years ago almost now, Milan needed to address decades of environmental degradation that was impacting agricultural output as well as regional development. Organic pollution of surface water from poor wastewater management impeded the crop biodiversity, leading to monoculture of low-value crops. And at the same time, there was increasing competition for water resources among Milan's industries and population growth. The solution there was to add a reuse treatment train when rebuilding two of the city's wastewater treatment plants, and to leverage ancient canals to deliver the reclaimed water to local irrigators. This led to improved water quality, restoring biodiversity, yielding higher value crops like fruits and vegetables. The use of the canals also boosted cultural heritage and ecotourism in the region. So sort of a double development of both agriculture and tourism economy. In terms of how it works, so Milan, the city charges irrigators only the pumping costs for supplying wastewater or reclaimed water. This is a rate that is made feasible because domestic wastewater customers are partly covering the cost of reuse and because of the clear value creation at the regional level beyond the utility. Milan was able to realize synergies from adding reuse onto traditional capital infrastructure needs and using existing distribution infrastructure as well. This case really illustrates, I think, the sort of system-wide benefits of reuse, which led to regional economic development. Another case study that I wanted to share with you is that of the Communauté d'Agglomération Royan-Atlantique, so CARA, in France. And this is one of the oldest reuse schemes in France and an example of urban applications in this case. So the CARA is the entity that is responsible for water and wastewater management of around 33 municipalities on the Atlantic coast. And that region is a tourism hotspot, and the population is actually multiplied by 6 during the summer season. So this leads to an increased demand for potable water supply during the summertime, while also resulting in higher volumes of effluent, of wastewater. And there's even actually one wastewater treatment plant that only operates during the summer to absorb those additional volumes of sewage. So to optimize water resources management and prioritize available resources for drinking water supply, the utility implemented reuse back in 1987, first to support commercial irrigation of the local municipal golf course. The project was developed further at the beginning of the 2000s years to irrigate another golf course, as well as to irrigate landscaped areas of a local hotel resort. What's interesting is that this project is continuing to grow. In recent years, increased drought episodes have sort of paved the way for the supply of reclaimed water for another application, agricultural irrigation in this case. So this is expected to start in 2025, so next year. Other potential reuse users have also voiced their concerns over water scarcity and the necessity to be included into the scheme to sustain their economic activity, like the local racetrack. So overall here, we see how reuse can really support and sustain the local evolution of a territory, including in the long term. And finally, we're turning to Belgium with the Water-Scarce project in the Port of Antwerp. So this project is still under development, but it showcases another interesting approach to industrial end-use applications. The Port of Antwerp is a major hub of industrial activities. It has its own sustainability strategy, and it aims to be climate neutral by 2050. And efforts to achieve this strategy include increasing circular economy, as well as dedicated funding for innovation. And so it's in this sort of innovative framework that the Water-Scarce reclamation facility is being constructed into the port. It will receive treated effluent from the municipal wastewater treatment plant of Antwerp, and the facility will treat it further to turn it into cooling water. The cooling water will then be supplied to industrial facilities in the port through a water as a service contract. It looks like it will be on a take or pay basis, where an annual volume of water is set and off-takers must cover the cost of that amount, of that volume, even if they don't need all of the water. So obviously there's much more nuance to all of this, but at a high level, I think those 3 case studies sort of demonstrate how utilities weight the underlying commercialization considerations differently and ultimately land on a business model and value proposition that best aligns with the local context. I think I'm running a bit up against the clock, but I sort of wanted to conclude today's presentation with some key takeaways on the factors coming into play into reuse projects. I think the key conclusion is that unfortunately there's no one size fits all when it comes to reuse projects. There's lots of different elements to take into account, different ways to combine those drivers, whether it is the policy framework, the local context, what are the profiles of potential customers, what are their activities, are there more irrigators with lands to irrigate, with crops to irrigate. Is it more a mix of urban applications with landscaped or areas to irrigate, landscaped area to irrigate, golf courses, more of a leisure activity? Is it more of a potential offtake with industrial customers? So taking all of those elements into account, and of course also the technical feasibility of the project, leads to the fact that every reuse project is extremely custom and unique in its own way. I think the value proposition of the utilities can take numerous forms, building on those constraints in terms of space and territory that the project is being developed. So lots of opportunities and lots of ways as well to shape municipal wastewater reuse and create opportunities. And that's it for me for today.
Oh, thank you, Chloe. Thanks for that insightful presentation. Do we have any questions from our audience? No one's writing. So yeah, thank you for all the cases you presented were European. Yeah. So in a maybe in a world view, where does Europe place itself with respect to the rest of the world?
So that's a good question. So Europe is definitely not the only region in which wastewater reuse is happening. Municipal wastewater reuse. The US are doing a lot of reuse as well. Singapore, obviously, it's probably one of the more most advanced countries in terms of reuse, along with Israel. Namibia as well started doing indirect potable reuse, I think in the 60s. So Europe is definitely not the unique region to do municipal wastewater reuse. In terms of how it compares to those other regions, I'd say we're probably a bit behind in terms of market maturity, just because we have a different set of regulations, or rather right now, the regulations tend to work sometimes against utilities or municipalities that want to develop reuse. In some places, doing potable reuse, for instance, is actually forbidden. So that's why the focus is so much on agricultural irrigation and growing urban applications. But yeah, I'd say compared to the US, for instance, which is in a market of more or less a similar size in terms of population or surface, I would say we're probably a good 10 years behind.
Oh, well, you mentioned that it was mainly agricultural. How about drinkable water? Is that current?
Yeah, so there are some indirect potable reuse projects in Europe, not a lot of them, but a few. I think one flagship project in France is the Jourdain project in the Vendée region, for instance. There's one also working in Barcelona, in Spain, one active in Belgium, in Torelle, if I'm not mistaken. So there are a few indirect potable reuse projects. So indirect potable reuse means that the wastewater is reclaimed, and instead of going directly back, if I can say, to the water treatment plant to be made potable, it goes through a buffer. So that buffer is usually a river. It can also be an aquifer, so doing artificial aquifer recharge and waiting for 6 months before abstracting the water to make it potable and supply it to the population. It can also be the same system with a lake, for instance, so recharging a lake and having a set waiting time before abstraction for potable supply. So indirect potable reuse projects exist in the UK as well, but for the moment in Europe, there's no direct potable reuse projects like we can see already in the US, for instance.
Well, thank you again for your presentation and for your answers. So if we have no further questions from our audience, I think we can call it the end of the seminar, of the webinar, sorry. Well, thank you all of the exposing members, Chloe and Assia. and all of the audience. So we wish you a very good end of the day, or well, beginning of the day, depending on where you are. Uh, and we'll see you soon. Have a nice end of the year, everyone.
Thank you. Thanks for attending. See you.
Thanks for attending, everyone.